Hi guys, welcome back to science. Hope you had a good day yesterday and did all the work that's been assigned to you. Hope you saw the announcement from the government yesterday. We're going to be moving to level 3 on Monday, and maybe some of you will be at school on Tuesday. However, if you can still stay at home, they recommend you stay at home. What we looked at yesterday were these chemical equations, and specifically the word equations. What we're going to be looking at today, though, are the chemical equations. So just going over one of these word equations. On the left, we have reactants. These are the things we start with. And then on the right, we have the products. These are the things we make. So if we get iron and sulfur and we mix them together and heat it up, they're going to react and make iron sulfide. This is a word equation, and down here is the chemical equation with the symbols. Alright, so we're going to look at what these symbols mean in a chemical equation. First off is just an O, which means one oxygen atom. Remember, O is the symbol for oxygen. So we have just one O, it's going to be one atom. If we have an O with a little 2 after it and under, that means there are 2 oxygen atoms and they are chemically bonded together. All of the oxygen that we breathe that's in the air is this type of oxygen, O2, and they hang out in pairs. This one here, O3, are 3 oxygen atoms bonded together, and this is known as ozone. You may have heard of the ozone layer or the ozone hole. So the ozone layer is a layer of the upper atmosphere, really high up, which has a lot of ozone in it, O3. And this is important because ozone absorbs ultraviolet light from the sun, which could be giving you sunburn or sun cancer. So O3, 3 oxygens bonded together. H2O, you may have heard of, it is water. And what that means is H2, 2 hydrogens and 1 oxygen atom. Like this. Oxygen, 2 hydrogens. And the last one we have here is H2O2. That's 2 hydrogen atoms, these white ones, and 2 oxygen atoms, the red ones. They form hydrogen peroxide. So hydrogen peroxide is a chemical. You can use it for cleaning wounds. Some people use it for that. You can use it for dyeing hair. So people with like real blonde dyed hair usually use hydrogen peroxide. It's also good for cleaning stuff. It's also super poisonous. But yeah, that is made from 2 hydrogens and 2 oxygens. You can see it looks very similar to H2O, except with just that little 2 on the end. While they look similar, actually if you look at them, they're both colourless liquids, so they also look very similar as well. One is extremely poisonous and one is essential to life. So that brings me on to my first very bad chemistry joke. All chemistry jokes are really bad. So there are 2 chemists, they walk into a bar. First chemist asks the bartender, can I have a glass of H2O? So hands it over, chemist drinks it. The other chemist goes, oh, okay, I'll have H2O too. Gives him the glass, chemist drinks it, and he dies. So now that we know what those letters mean, those numbers and letters mean, we can look at a big molecule like this and kind of work out what's inside it. So testosterone, it's a hormone. Lots inside. Men have more of it than women. And its chemical symbol is C19H28O2. So that tells us there are 19 carbons, 28 hydrogens, and 2 oxygens. And that molecule looks like that. So 2 oxygens, these red ones, 19 carbons, the black ones, you can try count them, and 28 hydrogens, the white ones. I hope you don't think in reality atoms are these colours. oxygen isn't red, hydrogen isn't white. We just use these colours because it makes it easy for us to recognise them when we look at a picture like this. All right, so moving on, if O2 is this, two oxygens bonded together, then in a chemical equation, if we put a big 2 in front of that O2, it means we have two lots of these oxygens bonded together. So that's O2. This is 2O2. 3O2. It's going to be three of them. This is very important in chemical equations, so we know how much of each thing is reacting. Here I've got two lots of C19H29O2. That means here is one testosterone molecule and here is another. The important thing to remember about these big numbers in front of the molecules, or in front of these things, is that these are not bonded together. This testosterone is not chemically bonded to that testosterone. That oxygen isn't bonded to that oxygen, okay? All right, so we're going to be balancing an equation today. Here is the word equation. Hydrogen plus oxygen goes to water. For a question, they will give you a chemical equation for that. So, hydrogen, the chemical formula for hydrogen is H2. Two hydrogens bonded together. The chemical symbol for oxygen is O2. Two oxygens bonded together. And the chemical symbol for water is H2O. Now, there's a one hydrogen. Sorry, there are two hydrogens bonded together. These are two oxygens bonded together. And there's a one oxygen with two hydrogens. Now, what we want to do is we want to have the same amount of each atom on each side of this arrow. So, how many hydrogens do we have on the left of the arrow? 1, 2. How many hydrogens do we have on the right of the arrow? 1, 2. That's good. How many oxygens do we have on the left of the arrow? 1, 2. And how many oxygens on the right? Just 1. So this equation doesn't really make sense because we lose an oxygen. What we have to do is change this equation to make it balanced. So the way we do that is first, well, what I'm going to do is I'm going to put a big 2 in front of the H2, and that means now we have two lots of these H2 molecules, and I'm going to put a 2 in front of this H2O, which means I've got two lots of water. Now if we show these molecules, so here are my two H2s, 1, 2, here's my one O2, and here are my two H2Os. We can count how many atoms are on each side and see it is balanced. So here I've got 1, 2, 3, 4 hydrogens on the left side of the arrow, and on the right I've got 1, 2, 3, 4 again. Cool. On the left side I've got two oxygens, on the right side I've got two oxygens. So this equation is now balanced. All right, just going to go over some more rules for this. So when balancing equations, you can only put numbers in front of molecules or atoms. You can't actually change the formula of the chemicals. So if I have O2 here, I can change it to 2O2 by putting a big 2 in front of that O2, or 3O2. That means I've got two lots of O2 or three lots of O2, but I can't actually change the O2 to O3. I can't change the oxygen to ozone. So here's my example. Here I've got an unbalanced equation. I've got one carbon on the left, one carbon on the right. Two hydrogens on the left, four hydrogens on the right. So at this point I've got more hydrogens on that side than that side. If I want to have the same amount of hydrogens on each side, and I can only put a number in front of one of my reactants or products, I can put a 2 here. So instead of C plus H2, I have C plus 2H2. That means each carbon reacts with two H2s to make CH4. Here I've got one carbon on the left, one carbon on the right, four hydrogens on the right, and 2 times 2 hydrogens here, which is 4 hydrogens on the left. So this one is now balanced. I'm going to show you how I do just one more, and then I'll give you some work to do. So on the right, here's an equation. Potassium, K is a symbol for potassium for some reason, plus O2 goes to K2O. So I look at this and I see I've got one potassium on the left, two oxygens on the left, and I've got two potassiums on the right and one oxygen on the right. The first thing I'm going to do is try to get the same amount of oxygens on both sides. I've got two oxygens here and one oxygen here. So in order to get the same amount on both sides, I can put a big 2 in front of this K2O. So what I have now is I've still got just one potassium on the left and two oxygens, but I have K2 times 2 is 4 potassiums on the right, and 2 times 0, 2 oxygens on the right. So we've got 2 oxygens on the right, 2 oxygens on the left, so the oxygens are balanced. But I've got 4 potassiums on the right and only 1 on the left. So what we have to do now is we put a 4 in front of this K, because we can put numbers in front. So there are now 4 potassiums on the left and 2 oxygens on the right. Sorry, 4 potassiums on the left and 4 potassiums on the right. So in total, if you count 4 potassiums, 2 oxygens, 4 potassiums, 2 oxygens, this is now balanced. Just be careful, when you put the 2 here to get 2 oxygens, you make sure that also doubles the amount of potassiums as well. Alright, that is quite complicated, so I've got a little activity for you to do. I'm going to put the link to this activity on the comments of this video, so when you finish the video, look at the comments. And this activity is this one here. Let's go back to the beginning. So it's going to start off like this. You're going to click on Introduction, and you're going to get a chemical equation. N2 plus H2 forms NH3. Is this balanced at the moment? In a way it is balanced because we have 0, 0, 0, 0 here. We have no atoms on the left and no atoms on the right. So yeah, it kind of is balanced, but not how we want it to be balanced. So what we're going to do is we're going to make 1 in front of everything. And now on the left we have 2 nitrogens and 2 hydrogens, and on the right we have 1 nitrogen and 3 hydrogens, little white dots. What we want to do is have the same amount of nitrogens and hydrogens on both sides. So in order to get 2 nitrogens on that side, I'm going to click up here. So now I have 2 NH3s, 1, 2. So 2 nitrogens on the left, 2 nitrogens on the right. And I've got, so that's good. Now we're going to have to do the hydrogens. I've got 1, 2, 3, 4, 5, 6 on the right. And I've got 1, 2 on the left. And there we go. Once I put a 3 here, 3 H2s, so 6 hydrogens and 6 hydrogens there, meaning it is balanced. Just a quick note here. if we wrote out this chemical equation, we would write it as N2 plus 3H2, then the arrow 2NH3. This 1 here, we don't write the 1. We just leave nothing there. Nothing there means 1. I'm going to just show you one more. Separate water. So let's just put 1 of everything. I've done this one already, I think. We have 1 oxygen here, 2 oxygens here. I'm going to need more oxygens on the left. I have 2 oxygens here, 2 oxygens there, good. Here I've got 2 hydrogens here and 4 there. I'm going to need 4 on each side, so I push up and we are done. When you've finished the intro, go into the game, try to complete everything up to level 3. This is the last one, real tricky, but I'm sure you will be able to do it. Alright, so for your work today, I would like you to do page 20 in your Scipad and this work, this game. So it's not much work, it does require a lot of thinking. Please read this stuff here and then answer the questions. So for balancing the following symbol equations, you are just going to be putting some numbers in front of these symbols. Yeah, so I'll let you do that page on page 20. But before you do page 20, do this game, which will be on YouTube. Cool. All right. That's all for me today, and I will see everybody tomorrow. Have a good day.